at the calculation of RWA. For instance, the key component is risk weight. Okay, if risk weight, to calculate your risk weight, you need your PD, your LGD, and your maturity. Okay, maturity. In essence, if you input a wrong PD into your formula, it's the system that will do the calculation. Okay, so but the information that you input into your system that does your risk engine that does the calculation is very, very important. If you input a lower PD into your calculation, so instead of having a PD of, let's say, 50%, sorry, it's too high. Let's say PD of 10%. Okay, and instead of inputting a PD of 10%, your system inputs a PD of 50%. What impact will it have on your risk weight? Any idea? All other attributes remains constant. All other parameters remains constant. If you incorrectly increase your PD by 40%, what is the impact on risk weight? What's the impact on RWA? And what's the impact on capital requirement? Any idea? Sorry, I'm trying to make the class a little bit interactive, so I'm not just the only one talking.
If the probability of default is increased, then the higher risk weight will be applied, which will in return give us a higher capital we have to keep apart.
Brilliant. And that way, thank you. So that's going to have an impact on the amount of capital that we need to set aside because we are actually inputting a wrong PD value for our counterparty or counterparties. And imagine, not having the right information in processing the right information in our risk engine, we have an impact on this amount of capital, and it will eventually have an impact on the amount of profit that the banks make. Because instead of you to be using the capital that you are setting aside against, such IPD, because you have a high probability of default, you have to set aside more capital. That money you are setting aside can be used, or lent to other customers. You can use it to purchase, other assets that can drive the revenue of the organization. So that's why you see that banks, they don't joke with the RWA calculation. This Basel requirement is not just for regulatory reporting purpose. It's very important for banks to understand the concept, of how these parameters are actually used for management information, for management decision making. You will see that a branch, they can decide to close, maybe Barclays Brazil can decide to, at group level, Barclays can just decide, okay, we want to cut our asset in Brazil, because the RWA is too high. Okay, they can make such decision based on the RWA calculation that we are doing, and it's actually not more than this. So not just for regulatory reporting purpose, this exercise, this requirement from the Basel Committee, they are very important for banks to make their own informed decision about what actually drives the profitability of the bank's asset, whether they should close down a particular branch or probably, increase funding or increase capital allocated to a certain area of the financial institutions department. Okay, so these are the kind of information that drives, or the impacts that this LGD, this PD, and maturity can have on the risk weight, and in turn have on RWA, and in turn have on the capital requirements calculations that we do for both informed internal decision making and for regulatory reporting as well. Any question before we actually go on again, before we move to today's class? Okay, so we stopped here last week, and we actually want to look at the calculation of risk weight. As I mentioned last week, we are not going to really focus on, this how the Basel Committee came up with this correlation or this formula, these formulas that we have here. We don't really need to spend much time on them in terms of how they actually come about this formula. What we need to understand, and it's very, very important, is that this correlation, for instance, these are the attributes that we used, or these are the formulas that we input into this capital requirement K to determine the risk weight that we need to use to apply to our EAD to arrive at risk weighted assets. So the first key parameter, formula is the correlation. Okay, if you have assets that are highly correlated, then there is tendency that the probability of default will be the same, and there is tendency that their default rate will are likely to be the same because the assets are highly correlated. For a non-correlated asset, then there is tendency that they are going to have a diverse, probability of default value. Okay, so for just look at the correlation. What this correlation stands for is looking at the correlation between assets, that actually are that highly correlated. Okay, assets that are highly correlated. What impact will the PD have? There is tendency for any asset that is highly correlated to have the same default pattern. Okay, if they're going to default, then we will be able to measure their default rate or probability of default. The pattern is likely to be the same. Okay, so that's what this correlation is all about. But what I want to lay emphasis on this morning is around, if you look at the parameter that we actually, that the correlation actually focuses on, is the PD. Okay, if you look at that, is the PD. There is no other attribute, risk parameter, that is present in this correlation. So which means that correlation focuses on the probability of default of assets that are highly correlated, the relationship between them. Okay, how do we measure the default rate of highly correlated assets? Okay, so if you look at it, we have correlation equals to 0.12 multiplied by 1 minus exponential minus 50 multiplied by the PD. Okay, divided by 1 minus exponential minus 50. All these are constants. They are given to us. Okay, and the idea is to be able to measure how correlated the assets that are within the same bracket, how correlated, the correlation between them. Okay, and we have 1 minus exponential minus 50. All these are mathematical formulas or attributes. Okay, we don't really need to focus on them, but what this correlation is measuring is the probability of default of assets that are within the same basket or highly correlated assets. Okay, and all you need to do is to input this PD value. So if I have a PD of 10%, then this value will be 0.10. Okay, and after getting this, this is the system that will do the calculation. For my years of experience of working on Basel, implementation, we've had not at any point in time have to use a calculator to do any calculation. The system, banks actually, whether they internally build their applications or they acquire a third-party application like Moody's Ray application, like RBM Algo Risk Engine. Some banks are already moving into cloud. We have used Platfora before in my office. Now we are migrating into Google Cloud Platform for our risk engine, for RWA calculation. So we'll be using Google Cloud Platform. Some banks, I believe Barclays are about to use AWS. I'm not 100% sure. So a lot of banks are moving into cloud in terms for their RWA calculations or for their risk engine. Okay, so it's the risk engine that does this calculation. It is not you. So either as a project manager or as a business analyst or as an implementation analyst or a validation analyst or a test analyst, all you do is the validation and verification and ensuring that you gather the right requirement. As a business analyst, what I'll be concerned about is what's the value of PD that we are inputting in this formula, not cramming this formula. Nobody will ever ask you, to highlight this kind of this formula, maybe in an interview or on the job. If you're looking to change, career, you want to move somewhere, nobody will ask you all this information in an interview or on the job, never. But what's the impact of PD that we input on this correlation value, on this formula? Okay, so those are the kind of things that you need to know. If you get a PD of 100%, what does that mean? That means the exposure is in default. Okay, which means that there is no need for the bank to set aside any amount of money against that exposure because the customer is already in default. Okay, so all we need to now look is to do recovery or to make sure that the bank gets their money back. And when PD is zero, which is very rare, but the closer the PD value to zero, then the lower the probability of default of the customer. Those are the kind of interpretations that we need to understand. And if we don't have a default, if we don't have a PD supplying to our risk engine, then we apply a default PD based on the exposure class. Okay, so we have 2.2 for sovereigns and institution and 4.3 CR rating, counterparty risk rating for corporate. So these are the kind of information that or knowledge that we need to have. Okay, so that's for correlation. If you look at this maturity, you will see same pattern. We have PD. Okay, maturity adjustment has to do with how do we adjust the maturity of the exposure. Okay, so it's a formula that has been given to us as well, and you can see it's a log that B equals to 0.1852 minus this multiplied by log PD raised to power 2. Okay, another thing is the same PD that you apply here that you are going to apply to this formula. It is the risk engine that does this as well. And this is where it is very important to understand this concept. We have capital requirement K. Now we allocate LGD, we bring in our loss given default. Okay, and we look at the inverse distribution. Okay, inverse normal distribution 1 minus r raised to power minus 0.2. We have PD. If you look at these values, these are and maturity, sorry. So in the calculation of capital requirement that we use to derive risk weight, the three key parameters as coming: the LGD multiplied by the normal distribution 1 minus r, okay, which is our correlation. You can see this R correlation here is here now. The value that we calculated correlation R, we are bringing it into the capital requirement formula. Okay, we are given our LGD, whatever the value is, if it's 35% or 45%, you apply it here. Normal distribution 1 minus this correlation, okay, minus 0.25 raised to power minus 0.25 multiplied by the PD. We have the same R here, the correlation minus 1 minus R again, then the PD multiplied by LGD. You can see this is a maturity. We are bringing in our maturity value now, which is the time to maturity or residual maturity. Okay, we apply that and we multiply it by this maturity adjustment because we need to make adjustment to our maturity based on the information given to us by the Basel Committee. So this is the capital requirement, and you can see we have incorporated the key three parameters that I mentioned earlier on that is required to derive our risk weight using internal rating-based approach: the LGD, the probability of default, and the maturity. Outside this, these are the parameters. These are the key parameters. I can't lay emphasis more on this because whatever happens to your RWA, whether it's going down or it's going up, is based on these three values. Okay, these three values, they have a direct impact on the risk weight and in turn on the RWA value of the bank. Okay, so that's the formula. Like I said earlier on, the system will do the calculation for you. Your understanding of the attributes that goes into the risk engine, that is very, very important, and how you interpret the result. Okay, a lot of people have, in my experience, a lot of people have the knowledge, technical knowledge, they have the, they have the technical knowledge, they have the capacity or capability, they have so many experience, in terms of when it comes to delivering projects. But when it comes to understand the domain knowledge, understanding the concept of this Basel requirement, it's very, very, some people don't have it at all. And how to interpret the numbers that comes out of your risk engine. That's where, they just do it in terms of managing resources, or maybe, gathering the requirements, but they don't have the domain knowledge of what Basel requirements, how to actually interpret the results that comes out of the risk engine is very, very important. So it will be good if we can, have this detailed knowledge in this class. Okay, so after calculating our capital requirement, please note this capital requirement K is different from the 8% capital requirement that we spoke about. I think it's quite confusing sometimes. I don't know why they are using this capital requirement and use capital requirement for calculation of the normal capital requirement that we need to set aside. There are two different things. Okay, you can see this formula is actually different. Capital requirement is 8% of RWA. Okay, this capital requirement of 8% is different from this. Please note that this is just used to calculate RWA, or risk weight, under internal rating-based approach. And this is the formula for this capital requirement K. So please don't confuse it with 8% of RWA. They are actually different. Okay, so to calculate our risk weight now, we have risk weight equals to this K, this capital requirement, in which we have incorporated our LGD, our PD, and our maturity values, and we multiply it by 12.5 to determine the risk weight using internal rating-based approach. For foundation, it's the same for advanced as well. Well, we are currently less focused on foundation approach. Okay, any question based on this slide?
No, all good.
All good. Okay, so let's move on to the RWA calculation. Like as I've mentioned earlier on, we have capital requirements is calculated using the regulatory formula. So this is in the previous slide. Sorry, it's a regulatory formula. It is given to us by the regulators. All the banks in the whole world that are implementing Basel requirements, we use that same formula to calculate risk weight for their foundation approach, under their foundation approach. There is nothing like I want to manipulate. You can't change it. Even based on jurisdiction, all the banks must use that same formula, okay, to do the calculation. Okay, so regulatory formulas is given to us based on the asset class. What do we mean by asset class? Our exposure class. So whether it's sovereigns, corporate, and institution, we use that formula for it. We don't use that formula for retail. Okay, so this for correlation, maturity, and capital requirement calculation is only for wholesale customers. Please note that it's only for wholesale customers. We will look at the capital requirement derivation or calculation for retail customers under advanced approach. We are not looking at it under foundation approach, if you remember, because we don't report retail exposures under foundation approach. These are the few, details that if, for instance, in case you go for an interview, these are the kind of information you pass across so that they know that, you let them know that, you know what you're talking about. You know that no bank can report retail customers under foundation approach. You either report it under standardized approach or it is reported under advanced approach. Okay, so based on the asset class, our exposure class, PD, LGD, and residual maturity, these are the key parameters that we use to derive, our capital requirement. PD, LGD, and residual maturity, as I've mentioned earlier. So the risk weight equals to 12.5 multiplied by K. We've discussed that. Then our RWA equals to risk weight multiplied by EAD. We already know how we derive EAD, or exposure value, for based on the product types that we have: the term loan, the letter of credit, the bond, and also the revolving assets. Okay. And the risk-weighted asset includes the scaling factor. We've discussed this last week. It's just a factor that is applied to the RWA. After we calculated our RWA, we increase it by 6%. That's what this scaling factor is all about, because banks are actually using their own internal rating models, and in a way, the regulators feels that there is a need to increase the RWA that banks are calculating using their internal rating based approach, because generally RWAs calculated using internal rating based approach are all lower than RWA calculated using standardized approach. So in order to create a balance between standardized approach and foundation approach or advanced approach using internal rating based model, the regulators decide to increase or make it mandatory for banks to increase their RWA value calculated using internal rating based approach by 6%. So your final RWA value equals to RWA multiplied by the scaling factor of 1.06. This is also applicable to all the banks across the globe, around the whole world. All the banks in the whole world that are using foundation approach must increase it by 1.06. It is not specific to a particular jurisdiction. Okay. So that is that about that. So the calculator used in deriving RWA value, it looks like this. Like I said earlier on, you cannot do this calculation manually. There is no time, because either a project manager will not be using a calculator to calculate RWA. All you want to do is to ensure that the project works smoothly, and you need a bit of understanding of Basel requirement as well. If you are working on the project and you are the project manager, you should be able to understand the impact of any changes you are bringing into your system, or any new requirements that comes from the regulators, or how your PD, LGD, and maturity will impact your RWA, so that when you go into a meeting, you're able to talk about these changes. If the key guys that are working, your SMEs, are, they come up with RWA has gone up by 2 billion, as a project manager, for instance, you should be able to question, our RWA last month was, let's say, 100 billion. And this week it has gone up to 200 billion. That's 100% increase. What has caused this increase month on month? This is not acceptable. What is it? Has the PD gone down? Has the PD gone up by 100%? Has the LGD gone up by 50%? What has caused this increase? But it's your understanding of this Basel requirement, and that's why it's good that you guys are doing this training, so that you'll be able to talk more about it when you are in your meetings and any forum that you find yourself. So this calculator is not every bank will have this calculator. They have, which is called risk engine. This calculator that I've put together can only calculate for one particular counterparty or obligor. Or as an organization, whether it's internally developed application or risk engine you are using, or whether it's a third party application like Moody's or IBM Algo Risk Engine, or let's say Google Cloud Platform or Platform or AWS, Amazon AWS, any cloud application you are using or any risk engine you are using, you should be able, the calculation will be done by the engine. Your own is to understand and validate the numbers that are coming from the engine, from the risk engine. Okay, so this calculator, we have our input fields, we have our EAD value. You need to input your EAD value into the system. Okay, your PD value into the system, LGD into the system. If you don't have any of these parameters, for instance, if your PD is blank, then you're not going to get, is either you get a null value, you are not going to get a right RWA value or risk weight value. Okay, because your PD cannot be blank. And if it's blank, is either the what comes out of the risk engine, the information that comes out of the risk engine will be blank as well. If the LGD is also blank or EAD, then you know that your value will also be blank, because these values are actually, they depend on each other. Okay, they are interdependent numbers. And if one is blank, based on the formula for calculating our capital requirement K, then it's going to give us a blank value. And which means that and this is where it's very important to understand the process. For PD, probability of default, they are derived, they are supplied into our risk engine. And if the file, for instance, in the file that we supply into or send into our risk engine, if any of these attributes is blank, that means that the output will be blank. So its input, what you send in, is garbage in, garbage out. If you send in a wrong information into the risk engine, then definitely your output will be wrong. Okay, or if you send an incomplete data into the risk engine, then what comes out of the risk engine is going to be a false information or an incomplete information. So that's why it's always key to get the right information into our risk engine. And that's why you see that banks, they spend a lot of money, to ensure that, right from the beginning of the credit process, right from the point that a customer or a counterparty goes into a branch or make a phone call to say, I want to borrow money from the bank. That's from that point we start gathering our data. It is not after we have given the money or lent money to a counterparty, that's when we start gathering the data. No, we start right from the moment any of our customer walks into our branch. We need this information to do our RWA calculation. And if we miss any key information at the point of, at the point of data gathering, when the customer walks into our office or walks into our branch or make that phone call, is going to have an impact on our RWA value. So that's why you need to understand the credit process as well, and knows how data drives the exercise that we are doing. And that's why banks invest so much, right from, developers, from requirements, business analysts, to project management, to implementation team, to BAU, and so on and so forth, because, everybody has their role to play in terms of data analysis, requirement gathering, and regulatory reporting of these risk parameters. Okay. Sorry, I often divert a little bit, but I think these are informations that we need so that we understand the process. Okay, so EAD, PD, LGD, then the time to maturity. You can see that these are the attributes that I've mentioned, since we started today's class. We have the sales turnover. I will touch these when we get to advanced approach, because this is actually required for the application of firm size. Okay, there's SME firm size. There is an incentive that the regulators have given to to small SMEs to ensure that, or encourage the banks to actually lend to SMEs. We have firm size adjustment. We need the sales turnover to be able to apply the firm size adjustment. It's actually here. We will discuss that when we get to advanced approach. We have default flag, which shows whether the exposure is actually in default, or the customer is actually in default or not. Okay, based on whether the risk weight calculation is different. It's actually different when the customer is actually in default, whether the customer is actually in default or not. Okay, the way we calculate risk weight is different. The formula is different when the customer is actually in default, or whether the customer is actually in default or not. Okay, we have the expected loss best estimate. We will see that impact when we get to advanced approach. Expected loss best estimate is actually applied to derive the risk weight when a customer is in default. And that's why I said, if the customer is not in default, you use the capital requirement calculation, where you use the PDLGD. You input all these parameters into the calculation of the capital requirement, correlation, maturity adjustment, and capital requirement. But once the customer is in default, at that point, this flag will be sent into the risk engine, and it will be populated as Y. And when it's populated as Y, which means the customer is in default, then you apply the concept of expected loss best estimate, or best estimate expected loss, which is derived based on the provisions divided by the EAD. We'll cover that under advanced approach. Okay.